would like to explain semiconductors. Materials can be divided into three types: conductors, semiconductors, and insulators. So while coming to semiconductors, the resistivity in between conductor and insulator, which is called semiconductor. So here semiconductors again divided into two types. Semiconductors can be divided into two types: intrinsic semiconductors and extrinsic semiconductors. Intrinsic semiconductors and extrinsic semiconductors. Again, extrinsic semiconductors divided into two types: N-type semiconductor and P-type extrinsic semiconductor. N-type extrinsic semiconductor and P-type extrinsic semiconductor. So here, coming to intrinsic semiconductor. What is meant by intrinsic semiconductor? The semiconductor which is in pure form is known as intrinsic semiconductor. Here, number of electrons equals to number of holes, means electric density equals to hole density. So that is Ni equals to N equals to P. So here electrons equals to holes. So number of electrons equal to number of holes in intrinsic semiconductor. The semiconductor which is in pure form is known as intrinsic semiconductor. The best examples are germanium and silicon. As per theory, germanium energy gap is 0.7 electron volt and for silicon 1.1 electron volt. So this is the theoretical value for energy gap in intrinsic semiconductor. So that the Fermi level diagram means the Fermi level lies halfway between the valence band and conduction band. This is valence band and this is conduction band. So here this is called Fermi level, means the energy gap lies between valence band to halfway between valence band and conduction band. This is in intrinsic semiconductor, the Fermi level diagram in semiconductor. So whereas coming to extrinsic semiconductors, whereas coming to extrinsic semiconductors. Extrinsic semiconductors divided into N-type semiconductor and P-type semiconductor. So first one is N-type semiconductor. N-type semiconductor. So what is meant by extrinsic semiconductor? The impurities are added to the pure semiconductor. Then it is known as impure semiconductor or extrinsic semiconductor. So what is meant by N-type? So N-type means pentavalent impurities are added to the pure semiconductors. Is known as N-type semiconductor. So what are the pentavalent elements? Phosphorus, arsenic, antimony, bismuth. These are the fifth group elements. So fifth group elements is grouping with germanium and silicon, means pure semiconductors. Then we will get N-type semiconductor. So here this is fifth group element: phosphorus and germanium. Germanium, fourth group element. So here the fifth group element added to the fourth group element. So here all the four electrons shared with nearest neighboring atom and formation of four covalent bonds in the N-type semiconductor and one more electron in the outermost configuration. So that the majority charge carriers are electrons and minority charge carriers are holes in N-type semiconductor. So here the electron in the outermost configuration is called donor. So which is called donor. The corresponding level is called donor level. So that how can you draw the Fermi level diagram? The Fermi level lies just below the conduction band. The Fermi level lies just below the conduction band. This is conduction band and this is valence band. So the Fermi level lies just below the conduction band in n-type semiconductors. So the majority charge carriers are electrons and minority charge carriers are holes. So this is called electron. So the particular electron is called donor. The corresponding level is called donor level. So that the Fermi level lies just below the conduction band in n-type semiconductor. Whereas coming to p-type semiconductor. So here p-type semiconductor. Trivalent impurities means outermost configuration is 3. Means the third group elements in the periodic table is added to means dopants to the pure semiconductor. That is germanium and silicon. Then it is called p-type semiconductor. So what are the trivalent elements? Boron, aluminum, gallium, indium, thallium. These are the third group elements in the periodic table. So what is the configuration? So this is boron, means the outermost number is 3, and doping with boron with fourth group elements, germanium or silicon. So here all the 3 electrons. So boron consists of 3 electrons in the outermost configuration. Okay. So all the 3 electrons shared with the nearest nitrogen atom and ready to accept 1 electron in the outermost configuration. So that the hole will be formed in the p-type semiconductor. So that the majority charge carriers are holes and minority charge carriers are electrons in p-type semiconductor. So here the corresponding level is called acceptor level. The outermost electron means ready to accept 1 electron means vacant electron is called acceptor. The vacant electron is called acceptor. The corresponding level is called acceptor level. So that how can you draw the Fermi level diagram? Okay. So here the Fermi level lies just top of the valence band. The Fermi level lies just top of the valence band. So here this is the acceptor level. So here in n-type semiconductor this is donor level. Whereas in p-type semiconductor the Fermi level is called acceptor level. So thank you all.